Discussing a recent symposium I attended, the Baylearn 2023. This is a machine learning AI community event here in Silicon Valley where researchers from universities and companies meet, discuss papers, listen to keynotes, and then obviously socialize. I want to focus on three things here. Number one, I met Percy Liang, I think a very interesting associate professor at Stanford. He has a couple of very interesting projects he's working on, in particular the benchmarking idea, which I think is crucial. Benchmarking is another word for trying to assess the validity of an AI model. And I think while this sounds pretty maybe technical and almost boring, in effect, it's the most interesting question in AI because what gets measured gets done. So if you can set up the right benchmarks, you will move the field forward. And since AI has such a big, space of mind, at least right now in society, questions about security of AI and all that kind of stuff, the alignment problem and fairness and a lot of deep philosophical questions actually surface once you keep digging into this. And I think Percy is a really interesting also personality. He seems one of those crisp, parsimonious scientists. He also has another project. He wasn't presenting it, but checking on his website, I learned that he's working on another project which is to standardize research. And I think what he's trying to achieve is that in machine learning, you have the ability to actually upload code into, let's say, a repository so you can replicate research. This is the key. So transparency, replication, and benchmarking. I think these are his key themes, which I think are really interesting themes in general. So this is the first thing I want to discuss. I want to discuss in general my impressions of talking to people, talking to researchers in the field of robotics, in the field of vision, in particular vision and rendering and video, generation of video, those sort of things. And then lastly, I want to talk about one specific idea that was presented here, and I think it's an idea that I've been playing around for a while, which is to use large language model architecture for video. And this was actually presented by a group from Berkeley at this conference. It's a Not Even Wrong podcast. It's October 20th, 2023. This is Crim Telco. It's the second episode. Today we have a more accurate update. Now the markets are closed. We're down 7.3% for the day. For the year, we are up 81%. The market is up 9.5%. We're outperforming by 71.5%. The sell-off of Tesla continues after earnings. We've had the first episode today was about the Tesla earnings call and the reset in growth, which is triggering a sell-off. We've discussed that in the previous episode. Now let's go into this discussion. So Baylearn 2023 is a yearly symposium about machine learning. I don't know how much cutting edge it is, but it seems to me really, really very, very cutting edge. You have, professors from Stanford, from Berkeley, and researchers from Google, Amazon, Meta, and many other companies present. So really a very, very I would say relevant and accurate mix of who's who right now in the field of computer science, in particular AI. And I think if you take, let's say, Percy Liang, which is one of the professors that I met, and this is the first thing I want to discuss here, is meeting people like that is very interesting because you see what they're doing, you see what's probably cutting edge. I mean, you can assume that computer science professors at Stanford will be, du jour when it comes to what is interesting, but that's not the point. I mean, you could go to any university around the world with some sort of reputation and have some, interesting conversations in computer science. But I think what's really relevant here is it's also pretty applied to industry. This is, I think, something that Stanford brings to the table. Just as a side note, I'm in the midst of a research project where I'm researching universities, in particular California, but in general universities. Well, what's going on? What's going on in the academy right now? And I think one of the conclusions I have, I'm also attending quite a bit of seminars now at Stanford, seminars in electrical engineering, in material science, in physics, in computer science, in AI, and then AI is subdivided in vision lab, and hardware, and in memory compute, things like that. So it's pretty broad. And my impression is that the Stanford culture is definitely applied. Stanford is about science that translates into technology and business. So this is number one, as opposed to Berkeley, which is just very high level science, Nobel Prize type winning science. So this would be just sort of a remark that I that I like to make, and let me give you a concrete example. So we have Berkeley is an institution that is really striving to do important science, and then hopefully also applies. And every now and then, an application sort of flips over into reality. So let's say, Databricks is a company that came out of the distributed computing efforts in Berkeley, which really go back to the cyberpunks in the 70s. Distributed compute, cryptography, make sure that the whole Bitcoin bonanza started at Berkeley with the cyberpunks and solving the Byzantine generals problem. So these things are related. So what I'm trying to say is that you have these big waves, these big scientific innovations that come from Berkeley. Stanford has that too. It's not like they're just doing Instagram type apps there, but Stanford is a lot more hands-on. What's the problem? What's the business? What's Sandhill Road trying to do? Sandhill Road is sort of the Wall Street of the venture capital industry. So that's where the money's being invested. All the VCs are there. So what is the relationship between Sandhill Road and Stanford? So for example, Chris Ree, one of the professors that was presenting yesterday, a colleague of Percy Liang, also very impressive personality, he spoke about the necessity to clean data, which is another thing I would like to discuss actually here in this episode. But so the necessity to clean data in the sense that data is a lot more important than models at this point. We've come a long way with models, and computer scientists, particularly mathematicians, like to work on models, but you actually have to have clean data. So Ray co-founded a company called Snorkel, which now is pretty successful in Silicon Valley, which is an auto-labeling company. And labeling pictures, just a very simple task, is actually pretty difficult and almost philosophical task. Okay, what does it mean? A beautiful woman on a beach. Am I going to label the picture a beautiful woman on the beach, or am I going to label the picture a desirable, sexy object on the beach, or a beach with a person on it, or a person with a beach behind it? Or this goes back to David Deutsch. Observations are theory law. And I mean, what exactly am I seeing? It's a theory. I have a model in my brain. I have expectations. I have lenses that I look through when I look at the world. So there's a lot of things that influence labeling, and Snorkel is trying to auto-label, on the one hand, make labeling easier, but on the other hand, also standardize it, which goes back to Percy Liang's work on benchmarking. So I want to talk about this now a little bit more. Benchmarking is, to me, the absolute holy grail of AI. Why? Because what gets measured gets done. So number one. But number two, it's also going to, think of benchmarking, it's like a holographic lens, right? And whatever comes through, whatever passes through that lens, that's what we're going to get in terms of AI. So if we benchmark for efficiency, we're going to get efficient AI. If we benchmark for fairness, we're going to get fair AI. Of course, that implies that we know what fairness actually means, which is, this is why I find it so fascinating that every time you start digging a little bit under the hood in AI, you end up with these very deep philosophical questions, such as the trolley problem, of course, in self-driving cars. But there's many of those. You want to have fair AI. Well, what is fairness? Do we even know what fairness is? Alignment problem. Fine. Alignment. What? Align what? But like, what are we actually trying to align for? Well, we're not really sure. The one side of the aisle wants socialism, the other wants, I don't know, individualism. So which one is it? How do we align? So a lot of deep philosophical, political questions that come up, and I think Percy is the kind of person that can handle this. I would say he's a very pragmatic person. He is not. I didn't get the impression of him as somebody who is trying to achieve greatness as a person. He will get there if he keeps doing what he's doing. But his main goal is really to solve the problem. He's in that sense a true scientist. Solve the problem, create new problems, solve those problems. Popperian scientist per se. Now, my question to him is really the most important question is the following. Look, I am a trained economist, so I've been going through this for decades now. I've been thinking about these problems. What is wealth? What is fairness? What is prosperity? What is liberty? What is all kinds of things, right? Well, what are they? And we don't have good answers for this because we all we are subjective, and I think that's why economics fails. I mean, economics has failed us clearly. Liberal democracies, in my opinion, are on the verge of collapsing because we have way too much debt, and the governments are creating these industrial complexes, military industrial complex, public health industrial complex, academic industrial complex, so all that stuff, and we're really, I would say, there's not a lot of hope for liberal democracies, but AI can save us because I believe that we can actually build agents that can help us benchmark. And we could do, let's say, just A/B testing, right? We could have two systems with agents with two different benchmarks, almost like maybe a GAN or something along those lines, and then let them compete for better benchmarks. Now, of course, better benchmarks implies that we have a sense for what is a good benchmark. And that implies that we have a sense for something like a ground truth, in a sense that we understand that we can dissect or we can discern what is a good benchmark and what isn't. So these are very deep questions, and I don't want to, I could go on for hours here. I think what I want to say here is, first and foremost, this is an area that I want to keep working on. There's a digital economy lab at Stanford, which is dealing with these problems. And I think Percy Liang is in the midst of it with his benchmarking approaches. And that's really what I want to take away here, first and foremost. Now, how does this tie into the purpose of this podcast, right? The purpose of this podcast is to give people a sense for what it feels like to run a hedge fund. Now, you can see here, this is a perfect example of a field that, in my opinion, has a lot more legs to go. There's a lot of opportunity here. There's a lot of problems to be solved. There's a lot of wealth to be created. This is the key. So if you want to be a hedge fund manager and you want to invest in innovation and technology, find an area like this, the benchmarking problem, and then keep working on it. There's no clear investment thesis right now, buy this stock or short that stock, none of that. But it's a field that is interesting. It's a field that is worth looking into. And I think this type of event, this Baylearn event that I went to yesterday, is a perfect example of how you can, maybe you look at a place that you might not even expect to be inspired to generate wealth, and then you find all these interesting ideas. So this will be the first thing I want to discuss. The second thing, I want to talk a little bit about my impressions in general. And this pertains to the AI community. The presentations that were made were, again, Percy Liang spoke about benchmarking. Chris Ree spoke about the necessity to adapt models to data and data to models. So he was talking, basically, he didn't say it that way, but he was talking about the stack. He was talking what Onur Mutlu was talking about, which is that we have a stack and we need to really think back into the stack when we to create models. For example, large language models are incredibly centered on one thing, which is a squared matrix, right? when you do dot products and when you calculate the way self-attention models work, which is what Ralws language models are based on, you're going to end up squaring matrices, so they scale with squares, so hold to the power of 2, and that is something that is not desirable because, of course, it's not scalable. In that sense, you want to find something more scalable. Now, he presented a solution that he borrowed from electrical engineering and signal processing. I don't know the details about that, and that's not important. But what's important here is really the idea that you have to think, okay, my model is based on, let's say, a squared matrix. And the squared matrix is going to make it very difficult for me to scale my model. So maybe I want to rethink my model. This is the main message that Chris Ray sent. So I think very interesting. Now, on the other side, there were talks by students, paper presentations, posters. I think the most interesting one was the one that I'm going to discuss in more detail later, so I just want to mention it here. It's basically an approach to use large language model architecture for videos, a group from Berkeley, which is interesting. Again, you can see that Berkeley is really trying to think more big picture, more deep, more scientific, with maybe less direct applications because there's way too much infrastructure necessary to make this work. But there is definitely sort of the seeds of a big breakthrough are being solved. On the presentations, I think there's been some good ones, some bad ones. You go across the field, and you can see like everywhere, even in this field, there's always sort of the 20% A+ players, and then the rest, and so on and so forth. I wasn't terribly impressed by, there were papers about, let's say, how to, analyze binary models. There were papers about how to, use machine learning for air traffic control, papers about, rendering, so using nerves to create three-dimensional pictures, which goes into the conversation that I had recently at Stanford with the information science lab proponent there. One is called Georg Wettstein or something like that, a German professor, very impressive. I want to talk about him a bit later. So in general, I would say my impression was that the field is moving forward. The field is looking at how to apply large language model architecture now to more, for example, there was a group from UC Santa Cruz, and they were looking at how to combine large language models with more specific models such as vision models or touch or Google search, like use specific, let's say, narrow vertical AI solutions and combine them with the big large language models, so kind of like a bit like a human that has a brain, and then different sort of applied intelligence such as eyes and touch and the skin and those sort of things. So they were trying to combine that and use reinforcement learning to better align these sort of adjacent models to the large language models. So I thought it was interesting. I think in general, again, I think what's going on right now in the AI community is, okay, we have the large language models, the self-attention architecture, and how can we leverage that into more applications, more, how can we learn how to use this now and get better results in several fields. I think lastly now I want to discuss one specific example, which is this group from Berkeley. I'm going to put the names in the show note in the paper. This group is specifically trying to solve the vision, generate videos. So the problem is how to generate videos, and can we do this by using large language models? And I think I am incredibly excited about this project because I think that if we can find a way to simulate nature in a more realistic or even close realistic way, then we can use simulation for self-learning, and that's how we can break through in robotics. So my point is that the breakthrough in robotics will happen, or the next step change in robotics, I should be fair to all the people, including Tesla, who are working on robotics right now, that the next big step change will come from self-play, and self-play requires an animation, and animation can be done by better, let's say, by generating videos. So video generation based on large language model architecture, that's what this group was trying to do. Again, it's early steps. One of the big questions I asked them is, okay, if you want to generalize the model in robotics in particular, don't you also need standardized, let's say, actuator technology and those sort of things? They agreed, but they really don't have solutions. So this is a very early stage. I think this is something that a company like OpenAI should take into account, and maybe not them, but something like that. We almost need like a non-for-profit research institution that does all the groundwork, the basic, like I said, let's say build an operating system for robots, have a standardized sort of actuator technology so that the software, the operating system can read what kind of actuators we have and then adjust the model based on the actuators so that the model can be that the model can be transferred, the learnings of the model can be transferred into any kind of robotics anywhere. So this would be definitely an interesting project. And for this, I want to actually quote something from a paper that I just read today. And it's not verbatim, but a good generalization is a model that can learn from past experiences and apply the learnings to new experiences. This is what a good generalization is. And if we want to do this in robotics using large language model architecture, we need to be obviously thinking a lot more across the stack, like I said, for example, actuator technology, but many other things, the operating system for the robots, and a lot of things that need to be solved before we can have such general artificial intelligence for robotics, which is really the end goal. So I think the Berkeley team is on the right path. The people were okay, like always, like, grad students or undergrads, they're almost, like, you almost expect them to be more impressive than they are. And I don't think this is, I wouldn't sell them short in any way. It's just typically what happens when you talk to, let's say you have this presenter who presents this really interesting idea, but then when you start digging a little bit more, then you realize there's not a lot of meat around the bone, but that's not their fault. This is how science works. This is an idea, and then you keep building this sort of avalanche of knowledge, and hopefully at the end you build a nice snowman. Sorry for the analogy, but it's just what came to my mind. So to summarize, Baylearn 2023 was a big success for me personally. I met Percy Liang, which is a very interesting personality, and I've learned a lot about what sort of the interesting fields in AI are right now, and one of them is benchmarking, and I think the other one is definitely thinking across the stack, be it through the lens of Chris Ray, who thinks what kind of models do we have, and what kind of stack do we need to support those models, and then what kind of models do we have, and can we change the stack or the models to be more efficient, to be more effective. And then we have the idea of applying large language models to more domains, in particular robotics, which I think is a very interesting field. Thank you.